So we are going to talk about how derivatives impact the shape of our graph. So we have been using our derivatives to find maximums and minimums. Okay, and we know some things. We talked about this from the very beginning. When your graph is increasing, what's true about our derivative? It's positive. When our graph is decreasing, the derivative is negative. Because if it's going up, those lines have a positive slope. When it's going down, they have a negative slope. So we already know how to tell if the graph is increasing or decreasing just by looking at the sign of the derivative. So that is the first thing here, the increasing, decreasing test. So you have a little box. It says if f of x is greater than 0, then, and then in the blank you should write f is increasing. If the derivative is less than 0, f is decreasing. So what's your problem? I want to know where this function is increasing and where it is decreasing. So we have to do what? We could look at a graph or find the derivative. Let's do that. So the derivative is 2x minus 4. And what we're going to do is find our critical points here. So where the derivative is 0 or undefined. Is this ever undefined? No. So we just need to know when it equals 0. So that's when 2x equals 4, where x is 2. Okay. Then what we're going to do is make a little sign line. Because we don't have our graphing calculators on a test, we can't just look at the calculator. We are going to figure it out. So we are looking at the derivative. Okay, what we do is we pick a test point. Give me a number smaller than 2 and a number bigger than 2.
3.
Okay, if you put a 1 into this derivative, 2 times 1 minus 4, is that positive or negative? Negative. If you put a 3 in, you get a positive. And we know at 2 the derivative was 0. So what we just found is before 2, my derivative was negative, and after 2, it was positive. So that means my original graph was decreasing on what interval? Negative infinity to 2, and make sure you use the critical point, negative infinity to 2. And then it was increasing from 2 to positive infinity. Alright. Is that one okay? Let's try one that has a few more critical points instead of just 1. So here is my function. To find increasing and decreasing, we need the derivative. What is the derivative?
12x cubed.
Minus 12x squared minus 24x.
Is this ever undefined? No. So I just need to know when it equals 0. What would you do here?
1x.
And
12.
then we could do the easy method. Squared breaks into x. What multiplies to negative 2 and adds to negative 1?
-2 and 1.
So what are my critical points?
0 to -1.
Those are the points where my derivative is 0. So that's where I change from increasing to decreasing. So to figure out what it is, we have to do a sign line. And we're going to put these numbers in order. -1, 0, and 2. Alright, I like to write my test points above this number line so I don't confuse them with my actual points. I tend to write these smaller. So something smaller than -1, in between -1 and 0,
Negative half.
between 0 and 2,
1.
bigger than 2.
3.
These are the test points. When I'm actually writing my increasing, decreasing, I'm going to use the -1, 0, and 2. So we need to test if the derivative is positive or negative. That is easiest to do just in the factored form. So if I put in -2, 12 times -2 is negative. -2 minus 2 is negative. -2 plus 1 is negative. If you multiply 3 negatives, what do you get?
Negative.
-1/2. 12 times -1/2 is negative. -1/2 minus 2, negative. -1/2 plus 1 is positive. So this is, okay, if you put in a 1, 12 times 1 is positive. 1 minus 2 is negative. 1 plus 1 is positive. So that's a negative. If we put in a 3, 12 times 3 is positive. 3 minus 2 is positive. 3 plus 1 is positive. So that's positive. Just a word of warning. A lot of times these signs alternate, but they don't have to. Things like squares can make you get the same sign twice in a row. When we start looking at rational functions or critical points when the derivative is undefined, we might get the same thing twice in a row. So don't just do the first one and assume you know the rest. You actually do have to check them because they aren't guaranteed. All right. So where is my graph increasing, Bill?
From negative to -2. Wait, increasing, sorry. From -1 to 0, and from 2 to infinity.
All right. Ben, where is it decreasing?
From -infinity to -1, and from 1 to, no, from 0 to 2.
Notice these points, -1, 0, 2. Those are my critical points. Okay, the critical points are where we change between increasing and decreasing. Is this okay with everybody? All right, we already kind of know how to tell if things are maximums or minimums. We've been doing it by taking critical points and plugging them into the function, right? But for that to work, for us to find that max and min, we were only able to find the absolute on a particular interval. We had to have endpoints and the critical points, and we checked them. If I'm looking for local maxes and mins, I can't just say, well, the highest number is the max and the lowest is the min, because we know there can be multiple local maxes and mins. So we can use this increasing, decreasing to help us. Think about what's happening. If you have a graph and it starts off decreasing, and then it switches to increasing, what was just formed there?
Parabola.
A parabola. And is this point a maximum or a minimum?
Minimum.
A local min. If your graph was increasing and then it switched to decreasing, what did you just get?
Max.
A local max. If you were decreasing and switched to increasing, you get a local min. So I could look at this right here and I could say, well, I'm going to have a local min at -1 and 2 and a local max at 0. So that's the next thing on your notes. The first derivative test tells you if it is a max or a min. They give you the rules if it changes from a positive to a negative. So that means it went from increasing to decreasing. So what was formed right here?
Local maximum.
A max. Local max. It would be what you write on your blank. If it goes from negative to positive,
Minimum.
local min. If it does not change, so if it's positive and then still positive, or negative and still negative, then there is no local max or min at that critical point. A critical point does not have to be a max or a min. It's just where we could find a max or min. All right. So, example 3, we kind of just did. It's the same function as example 2. I'm just asking for the local max and min from it. Okay. So if we reference back example 2, and we said that at -1, it went from decreasing to increasing. So what happened at -1?
Local minimum.
When you write this, you either have to give it to me function notation, like f of -1 equals blah, or give me an ordered pair. I don't care which, but you have to give me both the x and y values. So if you put a -1, how would I get the y?
Plug it in.
Plug it into the original. So we get 3 plus 4 is 7 minus 12 is -5 plus 5 is 0. All right. Then the next thing on my list, at 0, we went from increasing to decreasing. So what was 0? Local max. So when I plug in 0, we got out 5. And then at 2, it was decreasing to increasing. So that was local min. I put in 2. 2 to the 4th, 16 times 3 is 48. 4 times 8 is 32. So we're at 16 minus 40 is -32 plus 5 is -27. I would like for you guys to take a second and try example 4. So I want you to find your critical points and see if you can figure out if they are maxes or mins. -2 and 3. So you set your derivative equals 0. You factored out the 6. 6 doesn't equal 0, so we only get those 2 critical points. So we have to test smaller than -2, between -2 and 3, and bigger than 3. And we're plugging them into the derivative. The easiest place is to do the factored form. The 6 is positive, so that's not going to change anything. -3 minus 3 is negative. -3 plus 2 is negative. Negative times a negative is, if you put in 0, 0 minus 3 is negative, 0 plus 2 is positive. Negative times positive, if you put in 4, positive times positive is positive. So I didn't ask for increasing and decreasing, but you should be able to tell me, where is it increasing? Infinity, -2, unit 3 to infinity. We are. I'm just asking you this as a side note. Where was it decreasing? Okay. So the question was for the local max and min. And why are these local, not absolute? Did I give you endpoints? No. So we can't verify that they're absolute because we don't have endpoints. Okay, if your graph was increasing and switched to decreasing, then what happened at -2? And then if you plug that into the original, you get -16.
Oh, I did that whole line.
Is that right? And at 3, it was decreasing to increasing, so that would be a minimum. -74. I think. guys aren't checking, so we're
Well,
gonna go with
on the
it.
first one I got -93,